Hi there, this is Coach Suiso, and welcome to this video going over the multiple choice madness for Unit 7. Hopefully you took about 8 minutes on it. There's 9 questions. There's a 10th question on here, and I'll go through it with you, but it's from 714, which, as I said, is not tested on this because it deals with entropy and Gibbs free energy, and that is a topic that I reserve exclusively for Unit 9. So, as always, I've highlighted the correct answer. I've put kind of my tidbits of information as I solved it, and then, of course, I put the content and the area that you can find this information on the left. So the first question says we've got the airbags of cars. They're inflated with nitrogen gas via the decomposition of sodium azide. The reaction for this decomposition is shown. Which of the following is the equilibrium constant expression? So when I was doing this one, you got to notice your solids here. You have 2 of them, which means they are non-existent. They should go away. So all you should have left is that one product, which is the N2, and it should be pressure, and it should be cubed, which leaves me with A. Number 2 talks about a solid sample of silver sulfate added to a 1 liter of water. Concentration of ions was monitored as it was stirred, and here's my KSP. And the question says, does this reach equilibrium? And if it does, when? So remember, when you reach equilibrium, your concentration should have stopped changing. So, of course, we've got the presence of the silver sulfate all the way through it, but if you kind of look, we've got through here, we are changing our concentration of silver, but then between here and here, it reaches equilibrium because then you notice it stays the same. So somewhere between time 4 and time 5, which is B. C doesn't make any sense because it says the concentration of silver ions did not equal K. Concentration and K don't equal each other, so that's wrong. And then it says it reaches equilibrium between time 5 and 6. That's a common misconception because people look for the one where it stays the same. But if it's staying the same between 5 and 6, that means it already got to equilibrium. So it had to have gotten to equilibrium before 5. Number 3, the following reaction is represented by a series of images. We've got a nice little key up here. It says, given the images, which of the following statements is true when comparing the rates between time 0 and 1 and time 1 and time 2? So we are starting only with my reactant here. So that means my reaction between time 0 and time 1 must have been forward and only forward. So there's no way that B and D can be correct because both of those say that the forward reaction is less. You can't have a forward reaction that has a rate that's less because you're only going forward from time 0 to time 1. So we know those are wrong. So we know it's A or C. And then from time 1 to time 2, we hit equilibrium if you count across, so we should be at equal rates at that point. So when I'm looking here, that says A says the rate of the forward reaction is greater than the rate of the reverse. That's right. And then from time 1 to time 2, the rate of the forward is equal to the rate of the reverse because we hit equilibrium. Whereas in C, it says they're both 0, which doesn't make any sense. So A is the correct answer. 7.6 is kind of like one of those Hess's law, but remember, not Hess's law, it's for equilibrium, but it's only with one equation to make it really easy on you. So it says the equilibrium constant is this, and it wants to know how would you calculate Kp2 for the reaction below. So we've got a new reaction that we don't know about, but we need to do it in the framework of what Kp1 was. So when I look at these 2 reactions, how do I get them to equal each other? I have to reverse it, because this is on this side, and then I have to half it because there's 2 here and I need 1. So I'm going to reverse and half. Remember, reversing means I take 1 over that K, and halving it means I take it to the half, which is also square root, right? So when I come over here, it's going to be D. This one doesn't make any sense. They're not equal to each other. This one's just dividing it by 2. This one is just square rooting it. You need 1 with both, so it's D. Number 5, it says the equilibrium constant for the following reaction is here. It's the same as above. If I've got 2 atmospheres of dinitrogen monoxide added into a closed container, and then it's allowed to reach equilibrium, place the partial pressures of each component in increasing order. So this is very similar to that we did that one time that was a multiple choice where we talked about it. This is a very large Kp value. Very large. So that means we are going to be favoring our products heavily, like almost exclusively. So we need something where this one is the least. So here it's the greatest, that's out. Here it's definitely the greatest, definitely out. This one it's the least, which that could be right. But then it has these 2 being equal to each other, which is not the case because for every 2 nitrogens I form 1 oxygen. So it will be C. Number 6 says, given the following reaction, so we got our reaction written there. It says when 0.110 moles of AD is dissolved into 1 liter of water and allowed to reach equilibrium, the concentration of A2 plus is found to be this. calculate the value for the equilibrium constant. So I'm going to do an ice table. So this is like a common ion effect, just we're starting with the molarity of this instead of one of these products. So this is what I'm starting with. I don't have any of my products. And then I found at the end that this is my concentration, so I can populate this, therefore populate this, therefore populate this, and get all my concentrations, plug them in over here, and get a value. And it's written in scientific notation, but it is B. Number 7 says hydrofluoric acid, or HF, is a weak acid that's titrated with barium hydroxide. The overall ionic equation is such. Which of the following will decrease the amount of precipitate present? So remember, you need to know what a precipitate is. It is right here. Okay, it's that solid that's formed when you combine two solutions. And we want to decrease the amount. So basically, we need to move the reaction to the left. Okay, that's what we need here. So ultimately, we need to do something that's going to lower this. So let's look at all the wrong ones. So if I add barium nitrate, we're going to end up with more barium. So we'd increase this. So that means it would move to the right. That's wrong. If I add OH, I'd be adding this. That's going to be wrong because that's going to go to the right. We don't want that. Allowing water to evaporate would actually would change like all the concentrations, right? It would increase all the concentrations. But this is a solid, so that wouldn't affect it. So we need the addition of HCl, because if I add HCl, and this is just what we did in 713, I'm adding hydrogens, which would bond with this, which would lower that concentration, so it would all move left. Number 8 says the KSP of calcium carbonate is 6.0 times 10 to the negative 9. What is the concentration of calcium when the concentration of carbonate is 2.0 times 10 to the negative 5th? You just solve. It'll just plug it in and solve. I write my KSP expression, plug in everything that I know, and solve for calcium. Number 9, will a precipitate form? This is like that really monster beast of a question we did for the we-dos. If 1 liter of a 2.0 times 10 to the negative 5th molar solution of lead is added to 1 liter of a 2.0 times 10 to the molar solution of X minus, here's my KSP. So we're comparing KSP and Q. Biggest thing here that makes your life a lot easier is we're taking 1 liter and adding it to 1 liter. So basically we're doubling the volume. If I double the volume, that means I half my concentration. So I don't have to waste time like I did on that one beast of a question and like sit there and do M1V1. I know my concentrations when I plug them in for Q should be half of what they were. So I can get rid of C and D because they're not halved. So it's either A and B. And so then you just need to know like what's the Q value and what does that mean? So when I work this out with my new concentrations, I get a new Q value, which you can match to this, but it's smaller. And so if it's smaller, then no, I do not form a precipitate. Then there's number 10. You don't have number 10. Please do not stress about number 10. I did not include it on yours because this is what we're going to do in Unit 9. But in case you're kind of wondering what it was, we're going to be talking about, this kind of ties in with exothermic and endothermic and like lowering the water. But we're going to eventually talk about enthalpy, entropy, and Gibbs free energy. And when are reactions spontaneous? In this case, it's going to be a spontaneous reaction. So again, we'll get into that in Unit 9, but I got rid of it because I don't include entropy and Gibbs free energy in this unit. This will not be tested. It will not be like on the test in any way, shape, or form. So do not stress about that. That is all I've got for you on this. Let me know if you have any questions. I will see you Monday before the test so we can recap any of this. And once this is done, you may work on your OWL. You may work on your you-do questions. You may check you-do questions. And I also have the AP Classroom Progress Check multiple choice questions already live for you, so you can work on that as well. Have a wonderful weekend, and I will see you guys Monday.